Good morning. My name Murray Lamshed. I am just going to introduce the sine function to this class. They have done it before. It's only an example. I'm not going to write because we are projecting onto a wall for easiness. It'll give you a flavour of how I operate. I try to use technology wherever I can. Whether I write it as a PowerPoint or I bring it in from an applet from the internet, I will try to introduce these all the time. I am mainly concerned with trying to get the ideas across, because if they know the idea, they should be able to solve the mathematics problem. Thank you. Is expand the idea of the sine. We're going to talk about a sine function. Now, a function is where you have an x and a y and draw graphs and things like that. It's different from what you have been doing for sine. You have been using a function, but we haven't used that word. So we're going to do the sine function, which you know already, and it goes on. There we have it. What's the sine? It's the?
No, this is the opposite.
Opposite side. Why is it the opposite side?
Because there's
opposite
the
angle. And we go on, we have the opposite side, the other one, the long one is hypotenuse, and the one down the bottom, adjacent. We know that.
Yes.
That's the old trigonometrical, plain trigonometry idea. From that, of course, we get sine is opposite over
Adjacent.
hypotenuse.
Oh, hypotenuse.
You're right. Cos is adjacent over hypotenuse, and tan, and I have left tan out of this, opposite over adjacent, but I could include it if I wish to. So we have the old familiar sine is opposite over hypotenuse and cos adjacent over hypotenuse. You know that?
Yeah.
Okay. That's familiar to you, but now we go on with their idea. We have our familiar. Right. Now we're going to play a little game. That's what maths does, likes games. We're going to do a what if and see what happens. What if the hypotenuse is 1? So what do we have?
Opposite over 1, it means opposite.
And this would be?
Adjacent.
Adjacent, you're right. We immediately get down to, when I get the right button, there we are. So sine is opposite over 1, which means the opposite side is sine. And the adjacent side is cos. And that's what I say there. And we just go on to here. So this side is the sine of the angle, and this side is the cosine of the angle. Now we haven't got a calculator here, but if I had 30 there, sine 30 is a half, so this side would be a half, and cos 30 is 0.8660, and so this would be half a centimetre, and this would be 0.8660 centimetres. All because the hypotenuse is 1. Okay? Simple idea, isn't it? But we've gone out there. Well, we have one little interesting idea here. How do I know sine squared plus cos squared equals 1?
Because of the
Pythagorean theorem.
Yes.
Yeah, by Pythagoras. This is a very important trigonometry. We're not going to do that now. It's only a byproduct. Later you would do it, but right now I just want you to be aware that cos squared plus sine squared equals 1 squared. Pythagoras' theorem, you're right. You try it on your calculator when you go back. Sine 45 squared plus cos 45 squared equals 1. So it's quite good. Where do we go now? We need to get a bit further. We now come to the imaginative part. The ideas of Descartes, the French mathematician. We're going to put the x and y axis on our diagram and see where that takes us. There's the x and y axis. Here's the x and y axis. And that was Descartes' great idea in mathematics, a revolution in mathematics. I mean, not quite a quick revolution because things moved much slower in the 14th and 15th centuries. Not like overnight one, but it changed the way we did our mathematics. We moved from geometry to algebra. Anyway, let's see how we go. So, if you know, what's the coordinate of that point up the top there? What's the coordinate of that up the top of the diagram there? Up here.
Yeah.
It is like
Cos.
Yeah, it's cos theta, sine theta. And I have that now. See, that point is cos theta because that's how you plot it, isn't it? Cos x and then y. See how we moved? We've moved away now from sine and cos being the sides of a triangle to being a point up there. That was the big change. A bit more to come to it. Now the next thing we do is we allow this point, I have to change it all now, we allow this point, this line to rotate around. And wherever the point is, that is the cosine of the angle. Because I think you can see for every angle there's a point on the circumference, isn't there? So you now have that the coordinates of this point are the cosine and the sine of the angle. And look where that takes us. We now go over here to angles bigger than 90. This one around here. The coordinates of this point, which are cos and sine of that angle. And I could go down here, I can do over here. So we're now handling angles bigger than 90. In fact, we can handle every angle. Because if I stand here and go right around once more, it's got the same answer, because it's the same point. So that was the big idea. Let's read this over here. By letting the OP rotate by 1, this allows us to take the coordinates of any point on the unit circle. What's a unit circle? Unit means what?
Unit means 1.
1. And what was 1 here in the diagram?
What's the hypotenuse?
Oh, well, of the circle, it's the...
is it the radius?
Yes, the radius of the circle. Okay. We often use a unit in mathematics rather than a... It simplifies our working down, so we have the unit circle radius 1. All that happens if the radius is more than 1, you just enlarge everything. But it's easier to work with 1 rather than a large number. Right, so the unit circle, and these coordinates become the sine and cosine of the angle the arm has been rotated through. It doesn't actually matter which way we rotate. I didn't go into this, but we could come back this way and have negative angles now. See, we've just gone from ordinary sine and cos between 90 to any sine. 90, 180, 270, 360, 450, 540, all the angles. And we can go backwards, the negative angles.
Can I ask
so it doesn't matter which way we do. And there's a couple in the other. Here's a negative one. Here's the negative angle coming back. And this point here, its coordinates, its x value and its y value would be the coordinates here. Maybe the cos of this negative angle coming back. And here's another one in the third quadrant. Here is the first one again. And then if we go right around there, this point here, this is the cosine and sine of the angle. And we've really expanded our ideas now. And that's it. Okay? I have one more little thing to do that. I finished the last little section, now I'll just jump up to another section. What happens to this sine function? Now the vertical line is the sine here. What happens as this line moves around there? What's happening to the sine?
It's becoming larger?
It's getting larger. Now what's it doing?
It's getting smaller.
Getting smaller. And what's it doing now?
Again larger.
But down here it is
negative.
Negative. And over here it is getting
Smaller.
smaller.
Yes.
Okay? And if you think about it, cos is doing the opposite. Cos is starting off large, gets smaller, gets larger, gets smaller again, and gets larger. And we can draw a graph of that. Now, I would like to have a little applet of that, but I haven't. We'll just try and draw the graph of the sine function and see what it looks like. Here comes the graphing function, and if I just graph in quickly, because we're not doing the full lesson, sine x, you see you see the sine curve. Can you see how it starts off being small, gets larger and larger and larger, gets smaller again, gets into the negative, getting larger, and getting back again into there again. That is one complete turn, one cycle. The other parts, that's one cycle, that's two cycles, three cycles. It means something's going around. Okay? So there's an introduction to the sine function in 12 or 13 minutes. Okay, thank you very much. You may go back to your class. Okay. Well, that was an introduction to the sine function. Quick. I would usually go a lot longer. I had a couple of grade 9 students here because the other students are busy for exams. They were good grade 9s. And I would be using applets and other things, and I most probably would have a board here rather than a wall. But that's my way I would approach a lot of the work that I do, using applets, using calculators, using graphic calculators, using PowerPoint presentations, using anything I can put my hands on to use for imagery. They actually did a good job. I think they actually understood me, even though it's about a year ahead of where they are right now. Thank you for your time, and I look forward to a Skype talk. Thank you.